morning, students. In this lecture, I am going to solve the problems on Fourier transform. Write down, students. Find Fourier transform of f of x that is equal to 1 for modulus x less than 1 and 0 for modulus x greater than 1. 0 for modulus x greater than 1. Right. Hence, evaluate integral 0 to infinity sin x by x dx. Sin x by x dx. Solution, students. Solution. Given f of x that is equal to 1 modulus x less than 1 and 0 modulus x greater than 1. Modulus x greater than 1. Now, say students, find the Fourier transform. So, Fourier transform of f of x is f of s that is equal to f of x that is equal to integral minus infinity to infinity f of x e power isx dx. What, students? F of x e power isx dx. So, f of s that is equal to what is our function here, students? 1 modulus x less than 1 and modulus x greater than 1, the value is 0. Now, see, students, here modulus x less than 1, it means minus 1 less than x less than 1, students. Beyond minus 1 to 1, what is the value, students? The value is 0. The value is 0, students. So this integral minus infinity to infinity can be written as here, students. Integral minus infinity to minus 1 f of x. What is f of x? F of x value, students, 0 e power isx dx plus integral minus 1 to 1, students. Minus 1 to 1. F of x value, students, 1. So 1 e power isx dx plus integral 1 to infinity, students. 1 to infinity, again the value is 0 e power isx dx. So these two values are 0. Now e power x isx integration, students. So that is equal to, we get here e power isx by is between limits minus 1 to 1, students. Minus 1 to 1, that is equal to, substitute upper limit, students, e power is. What, students? E power is by is minus this time, students, substitute lower limit minus 1, so we get here minus e power minus is by is, students. So that is equal to e power is minus e power minus is by is, students. Is. Now everybody knows, students, e power ix, students. E power ix. What is small, students? Cos x plus I sin x. Now e power minus ix, students. E power minus ix, cos x minus I sin x. So this is 1 and 2, students. 1 plus 2, students. 1 plus 2. We get cos x is equal to, come on, tell me, cos x is equal to e power ix plus e power minus ix by 2, students. By 2. Because 1 plus 2 means sin 10 cos L, 2 cos x divided with cos 2, we get this one, students. Now 1 minus 2, students. 1 minus 2. This time, students, this will becomes minus, so we get here sin x is equal to e power ix minus e power minus ix by 2i, students. 2i. So see, students, here e power is minus e power minus is. So 2i, students. So multiply with 2 students. Multiply with 2 by 2. Okay students, 2 by 2. Now that is equal to 2 by s. What is the remaining term students? Sin x. That means here sin s, and s value is not equal to 0. S value is not equal to 0. Now this is the Fourier transform students. F of s, that is equal to 2 by s sin s. 2 by s sin s. Now what is say students? Evaluate, hence evaluate by using this result. Hence evaluate means using this result. Integral 0 to infinity sin x by x dx students. Sin x by x dx. To evaluate this integration, I am using inverse Fourier transform students. Okay students, inverse Fourier transform. So inverse Fourier transform. Inverse Fourier transform. What is inverse Fourier transform students? F of x, that is equal to 1 by 2 pi integral minus infinity to infinity f of s e power minus is x dx. What students? F of x, that is equal to 1 by 2 pi integral minus infinity to infinity f of s e power minus is x ds. So that is equal to 1 by 2 pi integral minus infinity to infinity. What is f of s students? We are finding here f of s. F of s value is 2 by s into sin s. That means 2 sin s by s into e power minus is x dx. See students, here whenever it is inverse Fourier transform, you always write here ds students, ds. Okay, ds. Now I compare these two students. I compare these two students. When I compare these two, here I have the extra term students. What is extra term? E power minus isx. E power minus isx. So I want to eliminate this term students. How can I eliminate e power minus ix students? By substitution. What students? By substitution. What is substitution students? Put x is equal to 0. What students? Put x is equal to 0. So f of here we have x students. So 0, that is equal to 2 cancel. We get 1 by pi integral minus infinity to infinity sin s by s. This value becomes e power 0 students. E power 0 value 1. So ds. That implies. Say students, here I want to write this first term first. Integral minus infinity to infinity sin s by s ds, that is equal to, you cross multiply pi students, we get pi f of 0 students, f of 0. Okay, 0 means here it lies between minus 1 to 1 students. 0 means it lies between minus 1 to 1. So the value students 1. So 1 students 1. Now I observe here sin s by s students, sin s by s. Now our limits are minus 0 to infinity students. Our limits are 0 to infinity, but I have here minus infinity to infinity. Minus infinity to infinity. So sin s is odd students. Sin s is sin s by s. Sin s is odd. S is also odd. So odd by odd students, we get even. Odd by odd, we get even students. So this can be, whenever it is even, we have a formula students. Integral minus a to a f of x dx is equal to 2 into integral 0 to a f of x dx. When it's students, f of x is even. F of x is even. So this can be written as 2 integral 0 to infinity sin s by s ds, that is equal to pi. That implies integral 0 to infinity sin s by s ds, that is equal to, divide the 2 students, so we get here pi by 2. 5 by 2 students. This is very, very important, students. This is very, very important. This is very, very important, students. Once again, given Fourier transform, students, f of x. Okay, students. Right, for formula, students, you substitute here, we get a Fourier transform of the given function, students. Whenever a given function integration like this, we are using inverse Fourier transform, students. Inverse Fourier transform. So f of x is equal to 1 by 2 pi integral minus infinity f of x e power minus asx ds, students. ds. Okay. Now you substitute f of x here and simplify it, you get finally answer, students. This is about the problem on Fourier transform, students. Hope you understand. Thank you for watching this video. Jai Hind.